Hello students. Earlier we learned about how you process an image using 8 by 8 smaller pixels. Now today you are going to learn how you are going to design a machine learning application using Labview and Python for an advanced example of predicting 0 to 9 digits using 100 by 100 and 28 by 28 pixels. Now as you can see on the screen, MNIST stands for Modified National Institute of Standards and Technology. It maintains a database of handwritten digits, has a training set of 60,000 examples and a test set of 10,000 examples. And each image is represented by 28 by 28 pixels, each containing a value 0 to 255 with its grayscale value, so called the intensity of the pixel. Now it uses the following libraries to demonstrate. NumPy, as everybody is familiar, this is a very standard library in the Python programming language, adding support to large multi-dimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. The libraries used in this example are TensorFlow. It's an open source framework of libraries for numerical computation and large scale machine learning. TensorFlow bundles together various machine learning and deep learning models and algorithms. Now, the other library which you're going to use is the Keras. Is on the other hand is a high level neural networks library which is running on top of the TensorFlow. Keras has a relatively simpler architecture than TensorFlow. Now I will just take you to the real application, how it looks like. This is a Labview project, you can see that, and it is called Keras project, and you can see that there are a few files in this. That is the main VI which you put on is here, and after you put on, you run this. When you run this, you can see that it shows certain things. It says it is a Python version, optimizer is Adam, and cross entropy is used, accuracy is used, and epochs is mentioned here. It says module compiling, and after some time it will go into the training mode. Then it will see, you can see that right now it has come into the training mode, and after training mode it will come into the prediction mode. So here the training, unlike my earlier example, the training is done using a standard images which are part of the MNIST. So you can see that now if I write 1 here, is predicting as 6, that is wrong. So now I draw 1 here, now also it is predicting as 6, that is wrong. Now I draw 0 here, it is predicting as 2, that is also wrong. Now I write 1 here, so it is predicted as 1. Now let me write 2 here, is predicted as 2. Like this it will be able to predict one of the 9 possibilities. Now we go back to the presentation. where we had stopped. So as I said, the program code, the Python code which does this, is it is using import numpy as an instance NP, and TensorFlow. From the TensorFlow we are using Keras library we are importing. And what we are doing, we are going to call all the trained images and labels from MNIST. So I call this MNIST is equal to keras.dataset. Complete dataset is called from MNIST. All the trained images are called here, and here so-called the test images are also called from there, and we have to the test labels, what it means, that is also called from there. Train labels are also called from there, and they are loaded here. After that, this is just some manipulation of the intensities to come in 0 to 1 format instead of 0 to 255 format. Now we are calling the model into 28 by 28 pixel, and the activation function is a relu, and the output layer is softmax. And there are some functions below that which we will explain one by one. The model definition. The model is defined to have 3 layers. The input layer consisting of 28 by 28, that is 784 nodes for each of the 784 pixels in the digit image. There is a hidden layer consisting of 128 nodes, and activation function is relu. So those who have understood what is deep neural networks, you must have come through one input layer, there's a hidden layer, and output layer. This is what is the input layer. Output layer is just 10 outputs. It's a 10 class problem predicting 0 to 9. And first you compile. What is compiling? Compile is, the model is compiled using optimizer Adam. In convolutional neural networks, you must have learned about little bit about the optimizers, so-called the grids or filters. All these things you must have learned. And loss is cross entropy, is a probability based, where there were different losses. We used squared losses, cross entropies. Then the metrics for the evaluation is the accuracy test. That is what we do. The function, Python functions called from Labview are, you know that this is a module, is a diff, is basically defining a function, predict is another function, and it's returning the results here, returning the threads here. And this is a function in which it is taking all trained images and trained labels, and it goes through epochs. Epochs is the number of times to train to achieve the one full result. And here it has got some more arguments to this. So this is being called through Python. You have also learned how in my earlier videos, how can you call this module from Labview using a invoke method. If you have not seen that video, you may go and see how you can call a module or a function from Labview. So these two functions are called from within the Labview. And now the image is 28 by 28, and that is what is used for the prediction, and finally the predicted output comes in. So this training model is like this, fits a model that we built with the train images and number of epochs specified. Epochs, what is epochs? Epochs is one complete pass through the training data. It is typically to train the deep neural network for multiple epochs. It is also common to randomly shuffle the training data between epochs. The model is then evaluated on the test images, and the loss and the accuracy is stored. After every epoch, loss is expected to reduce and the accuracy is expected to improve. But it may not always happen. Remember, model predict is the function accepts image drawn by the user as 28 by 28 array and predicts the highest probability of the class or the digit from 0 to 9 which the input is closest to. The prediction is returned to the LabVIEW VI as the final output. If you look at the LabVIEW screen, you will see all these things behind. If you do Control E from the main screen, which I just demonstrated to you, you will see how this is calling a module, a Python module definition, a diff function from LabVIEW. So you know that to call that you have to first define the session you have to open, then you have to close. In between you have to call the invoke the function. So how do you do that? So this is opening the session. This is the module called the module compile you are calling. This is a function name. After that you are passing the data types. These are the three arguments, if you remember. And the data type, and it is also calling so-called the main.py, which was a file which is sitting part of the project, which is being fed inside. Now this is another module which is called model training. In this model training, you can again see the module which you are going to use is the training module, which we earlier showed in the form of Python, and this is an array type of input, and this is number of epochs. This is a number which you are giving 3 or 4 or whatever. Results are coming out in the form of loss or accuracy. Now the sub VI which are used, there is one sub VI which is used. I'm sorry, I earlier said it is 100 by 100. Now it is 280 by 280 pixel input. That is reduced into 28 by 28 without losing the information using a program which is here. This is a LabVIEW program which you can do that, and that is being fed as the input to the entire system. And final predicted output is on. You can see that this is a model predicting program which predicts any one of the numbers as the output. Now this has been taken from a working example from the internet for demonstrating this purpose, and I have modified and explained in a better way. And this kind of a program you might see at the internet with less explanation. So if you go back and see the exact program which was running was like this, and you were able to predict an output using this application. And if you want to see what is really happening behind, you can press Ctrl E on the screen like what I did. Whatever I explained, the modules, compiling part, the function being called, model compile is being called, model training is being called, all those things are in a sequential way they get executed. So this is a very good example of working example which can predict the exact number you are interested.